My dear student of class 9, in my previous physics class, I discussed about the Newton third law of motion. Today, we discuss a new topic, that is principle of conservation of linear momentum. So therefore, first you have to know what is principle of conservation of linear momentum. According to this principle, the total linear momentum of an isolated system always remain conserved. So therefore, what do you mean by isolated system? Isolated system means this is the system on which there will be no external force acting on the system. Now we have to prove this statement. Now see the board very carefully. Here we consider there are two objects of mass m1 and m2 moving along the same straight line with a velocity u1 and u2. When u1 is greater than u2. So as u1 is greater than u2, at certain instant of time they are collide with each other. So this is the situation before collision, this is the situation during collision, and after collisions they are separated from each other and moving with a velocity v1 and v2. So this is the situations after collisions. To change the velocity from u1 to v1 and from u2 to v2, the time taken is t, suppose. So therefore, we know that during the collision, m2 creates some force on m1 and m1 creates some force on m2, which are known as actions and reactions. So therefore, the force on 1 by 2 is equal, from the Newton's second law we know that force is equal rate of change of momentum of the object m1. So therefore, F12 equal, what is the rate of change of momentum of m1? Change in momentum by time taken. Change in momentum means final momentum minus initial momentum. What is final momentum? m1 v1 minus what is initial momentum? m1 e1 by time taken. So therefore, F12 equal m1 v1 minus m1 e1 by t. Clear? Similarly, the force on 2 by 1, F21 equal rate of change of momentum of the object m2. So therefore, F21 equal change in momentum of m2 means m2 v2 minus m2 u2. m2 v2 minus m2 u2 divided by time taken. And according to Newton's third law, we know that actions and reactions are equal in magnitude, but their directions are opposite. Means these two forces are equal in magnitude, but their directions are opposite. Therefore, we can write F12 equal minus F21. So in place of F12, we can write m1 v1 minus m1 e1 by t is equal minus, in place of F21, m2 v2 minus m2 u2 by t. Both side tt cancels, then m1 v1 minus m1 e1 is equal minus m2 v2 minus minus plus m2 u2. If we move this m2 v2 to the left, it becomes plus, and if we move m1 e1 to the right, it becomes plus. So therefore, expression m1 v1 plus m2 v2 equal m2 u2 plus m1 e1. This represent the total momentum after collision. This represent the total momentum before collisions. So therefore, according to the principle of conservation of linear momentum, we can say in the case of collisions, the total linear momentum of the system before collision should be equal to the total linear momentum of the system after collisions, and this is known as the laws of conservation of momentum. Now, using this conservation theory of momentum, we can explain the various phenomena which are happen in our surroundings. Number one, man and boat. Now, whenever a man from the boat try to reach to the shoreline of the river, then the boat move in the backward directions. Whenever the man jump from the boat to the shoreline, whenever man is on the boat, near the shoreline, then before jumping, the total linear momentum of the man and boat is 0. And whenever man is jumping on the shoreline, there will be some forward momentum created or generated in the man, and to conserve the total linear momentum which is 0, a backward momentum is created on the boat by which the boat move in the backward directions. Secondly, gun and bullet. We know that whenever we fire a bullet from the gun will move in the backward directions. This can be also explained with the help of conservation of linear momentum. Before firing, total linear momentum of gun and bullet is 0. But whenever we fire, after firing, the bullet gets some forward momentum, and to conserve the linear momentum which is 0, the gun will get a backward momentum by which the gun moves backward with a velocity. And thirdly, rocket and hot gases. Now, before burning of fuel of the rocket, the linear momentum of rocket and the hot gases system is 0. But whenever the fuel is burning, the hot gas ejected from the backside of the rocket with a high velocity means it have a backward momentum. To conserve the total momentum which is 0 actually, the rocket get a upward or forward momentum by which the rocket moves in the forward directions. Okay, so these are the phenomenon which we can explain with the help of conservation of linear momentum. Now student, this is all about your theoretical portions of this chapter. Now see, there is one numerical. A constant force of friction of 50 Newton is acting on a body of mass 200 kg, moving initially with a speed of 15 meter per second. How long does the body take to stop? What distance will it cover before coming to rest? Now, here, during the motion of the body, a force of friction of 50 Newton acting on the body by which the body finally comes to the rest position. Rest means the final velocity of the body is 0 and the initial velocity of the body is 15 meter per second. So means there will be a retardation acting on the body which is A equal F by M equal F is how much? 50. Retardation means this is a minus and mass is 200. So therefore minus 0.25 meter per second square. So this is the retardation with which the body actually moves. Now to determine the time to stop, you have to use the formula V equal U plus AT, because V is 0, U is 15, A is minus 0.25, time you have to determine. So therefore time equal 15 by 0.25 equals 60 seconds. So now you have to determine the distance covered by the body before coming to rest. So how can you determine the distance? To determine the distance you have to use the formula S equal ut plus half at square. S equal U means 15, time is 60, A is minus half into minus 0.25, t square means 60 square. After calculating this, you got S equal 450 meter. So this is the distance covered by the body before coming to rest. Now there is a very important applications of the theory conservation of linear momentum, that is a recoil velocity of gun. Means with what velocity a gun moves in the backward direction during the firing of bullet, you can determine. Now see the calculations. Let a gun having a mass capital M and bullet having a mass small m. Before firing, gun and bullet both are at the rest position, that's why total momentum before firing is 0. Now you consider after firing the velocity of bullet is small v and the velocity of gun is capital V. So means after firing both the bullet and gun have some velocity. Means the total momentum of bullet and gun system after firing is mv plus mv. This is a momentum of gun and this is a momentum of bullet. And according to the principle of conservation of linear momentum, we can say the total momentum before firing should be equal to the total momentum after firing. That's why we can write mv plus mv equal 0. From here mv equal minus mv, so capital V equal minus mv by capital M. So this minus sign represent that the direction of capital V means the direction of motion of gun should be opposite to the direction of motion of bullet. That's why this velocity of the gun is called the recoil velocity. Now student, see this chapter very carefully. I will provide the remaining NCERT solutions very soon. Thank you.